Steve Gnas with Discovery Designs Refrigeration. In today's video, we're going to do a demonstration that's going to show you the importance of evacuations in refrigeration systems. Really what's going on when we're doing evacuations. All right, now what we're demonstrating here today is deep vacuums, specifically for boiling evacuations. In industrial systems, we're typically using inches of mercury to measure our vacuums. In this case, because we need to pull deep vacuums, we're going to use a much more accurate means of measuring our vacuum. That unit's going to be microns. So how much more accurate is a micron? Well, 1 inch of vacuum equals 25,400 microns. So when we're talking here about vacuums in the hundreds and even thousands, it is a unit that is significantly smaller even than 1 inch. Now, why do we need to get so deep? Well, on an ammonia system where there's hundreds of thousands of pounds of ammonia, a drop or two of water isn't going to make a big difference. On halocarbon systems or CO2 systems, water can be hazardous to the system. CO2 in particular can combine with water to form carbonic acid. So using these systems, evacuating the initial piping or even evacuations after servicing systems is a critical point. So how deep of vacuums do we need to pull? Well, in our experience, what we've found is that if you're pulling a vacuum and it will not get below 1200 microns, you either have a leak or you have moisture in the system. Oftentimes it'll sit there right at 1200 microns, or if you are able to pull down to say 500 microns and turn your pump off, in a relatively short time, that pressure will come up back to 1200 microns. So the point of what I'm explaining here is when you're pulling your vacuums and you get below about 500 microns, you should be able to turn that pump off for 20 minutes, half an hour, and it should not rise back up above 1200 microns. If it does, you either have water or you have a small leak somewhere in the system that you need to find. So here we started to pull it down. There is a drop of water in the bottom of this, and we are going to basically evaporate that out by dropping the pressure. All right, now as you can see, the vacuum is pulling down here, and we're getting close to the point where those couple drops of water are going to hopefully evaporate here for us. It's really tough to show on camera. We tried a couple different angles, but to look through the glass and actually see a clear substance that's only a drop is pretty much impossible, so you have to bear with us here. But we've just crossed over that 1200 micron threshold that I was talking about earlier. Now what you're going to see is the pressure is going to come down and it's going to jump up a little bit. When it does that, that's the last couple of drops of water in there evaporating. And what you'll see when that happens, if you could see it, you'd see that the water is turning basically to a vapor and then dropping away. So once the last little bit of water comes out of that, our vacuum will keep coming down, and we'll be able to say that we've removed all the water from the system. Now you can create a situation where you'll show 500 microns. When you turn a vacuum pump off, the pressure will come back up. If you turn it off and it stays at 500 and doesn't come back up, you definitely have a very tight system that has absolutely no moisture in it. And that's ultimately what we're looking for. Okay, now you're going to see the microns start coming down. Depending on how big the system is, how tight it is, and how your gauge is, it'll stop somewhere between 600 and 400 microns generally. Sometimes some specifications will call for a triple evacuation, where you'll pull to specific microns and then you'll break either with dry nitrogen or with refrigerant, and then pull down again. You can get very small amounts of water that'll actually crystallize in terms of the ice when you release the pressure. You need to bump that pressure up and then bring it back down again to actually get it to come out of the system, because if it does solidify, it will not vaporize using the pressures that we have here. So if you have a specification that calls for that, that's the reason. But typically, once you can pull down and hold something under 1,000, 500 if you can, your system is free of any type of moisture that you need to be concerned about. At that point, you need to break the system with refrigerant and begin your refrigerant charge. I hope you enjoyed today's video and learned something in the process. If you have any questions about this or any other things in a refrigeration system, please feel free to reach out to me through our website or through email. Thank you.